So, welcome back. Now, we are moving on to the most important language that we will study in this course, which is the language of first order logic. And we have just finished studying propositional logic, which is the logic of sentences. The main advantage of studying propositional logic was that we could get a feel of the semantics of the connectives and the proof methods. So, we saw a couple of proof methods, but propositional logic is not expressive enough to do most things. In fact, the most of the stuff that we do in computer science, including programming, would come into the scope of first order logic essentially. So, let us begin with that. Just a quick recap of what is it that we are studying logic for. A logic is a formal language that defines a set of sentences. So, we have seen one formal language, which is propositional logic, and today we begin on the second one, which is first order logic. Whatever the language that we are using, we will always refer to sentences in logic with these symbols alpha, beta and gamma and so on. Now, each sentence has a meaning, but the meaning is ascribed from outside. Likewise, each sentence has a truth value, which is also ascribed from outside. So, what this means is that the logic machine in itself is devoid of meaning totally essentially. It is just a syntactic pattern matching and procedure in which you match some patterns and you add new patterns and so on essentially. Compound sentences have truth values that are determined completely by its constituents and logical operators essentially. In fact, it is the fact that we have these constituents and these logical operators is what allows us to make inferences. So, our favorite rule of inference said that if you have alpha implies beta, and if you have alpha, then you can infer beta. That is because you can see that there is some connection between the first two sentences alpha and beta, and alpha is common, and of course, the meaning of the logical connective will tell us whether we can have beta or not, and we have studied this quite a bit by now. So, we have the notion of entailment in logic. So, we say KB entails some formula alpha. We also have a notion of rule of inference and a notion of provability. So, we have a machinery of algorithms for producing new sentences from old by applying rules of inference, and if we can produce a proof, then we write this as alpha. And obviously, we studied the notions of soundness and completeness, and we said that the goal of building the machinery that we are building is to mechanically produce all and only the true sentences or conclusions given a set of true sentences. So, you give some input, a set of axioms or a set of premises, and whatever is entailed by that, whatever conclusions hold logically, we should be able to produce using this syntactic procedure of theorem proving or adding new formulas till we have added the formula that we are interested in. Now, we said this before that propositional logic does not allow us to peer inside the sentence. So, we might use a sentence like all men are mortal, but we do not look at the words in the sentence and the meanings of the words and their relation between each other and that kind of stuff. We just say okay, this is some sentence P essentially. On the other hand, deduction is possible because of connections between constituents of sentences essentially. So, we just mentioned this modus ponens, we have alpha implies beta and we have alpha and we can infer beta, and there are connections here. So, the alpha is the same in the two inputs, and that allows us to carry forward the beta from the first input into the conclusion essentially. So, looking into sentences, at least compound sentences in the case of propositional logic, allows us to make these connections and do the logical deduction. We need to do something similar with first order logic as well. So, the pattern that we started with early, this syllogism or the Socratic argument. If we just treat each of them as each of the sentences as propositional, then there is no way we can derive the fact that Socrates is mortal from the sentences that all men are mortal and Socrates is a man. We need to deconstruct the sentences and look at the components and the constituents, and that is what will give us the connections between the two premises and the conclusion. So, for example, men, we are talking about men in both the sentences, we are talking about an individual called Socrates in both the sentences, and we are talking about the property of mortality in both the sentences, and it is between these interaction between these things that we can recognize which are valid forms of reasoning and which are not valid forms of reasoning. So, we need to deconstruct sentences, we need to peer into sentences and break them into smaller parts, and then the reasoning will be possible. The form of the argument captures the connections. So, alpha implies beta and alpha captures the connection between the fact that alpha is the antecedent in alpha implies beta and alpha is also given to us. So, when alpha is given to us and when alpha implies beta is given to us, we can go and infer beta essentially. Propositional logic cannot make these sentences, at least in the example that we have on the right hand side. So, we want to now upgrade in some sense to more expressive logic, which will allow us to talk about men and mortality and so on. So, the syllogism was invented by the Greeks, in particular Aristotle was the person who did a very thorough analysis of what are the valid forms of reasoning. Remember that we got into logic to start with to recognize valid forms of arguments or valid forms of reasoning, and Aristotle spent a lot of time looking at that. He was looking at the world from the perspective of categories and individuals. So, by categories we mean classes or types of things. So, for example, man, mammal, animal, all these are categories essentially, and individuals are of course individual members of the world that we are talking about, and we will try to formalize this. So, he was interested in making statements about categories essentially. So, he identified 4 kinds of statements that are interesting. The first is called universal affirmation. It says that all S are P essentially, and the example that you can remember is all men are mortal. I have written the categorical symbols here in red color. So, you can recognize that which part of the sentence refers to category and which part is something else. In some sense they are part of some connectives. Then we have particular affirmation that some S are P. So, you might say for example, that some children are tall. We will deal with these kind of sentences as we look at first order logic. Universal denial, no S is P. For example, no priest is immortal. And particular denial, some S are not P. So, some birds are not priests. Of course, you might argue that no birds are priests, which is also a true statement, but that does not take away the truth of the statement that some birds are not priests. In a similar fashion, if I had said that some men are not mortal, that would be a true statement, and when we as human beings talk about such statements, we tend to make some inferences which are kind of not justified essentially. So, that if you say that when you are saying that some men are mortal, it does not by any stretch of imagination imply that some men are not mortal. We are not saying that. If we wanted to say that, we would have said no man is mortal or something like that, or all men are not mortal or something like that. When we say some men are mortal, we are just making a statement. There is at least one man who is not mortal essentially. So, these are the 4 kind of connections that Aristotle recognized, and of course, we have to talk of individuals. If we have to talk about things in the real world, we are interested in individuals, and the simplest kind of statement about individuals is that X is a P essentially. So, Socrates is a man, for example. So, the argument that we looked at is the Socratic argument, as we called it, is one of the 14 valid forms of syllogism that Aristotle identified, and this is just to remind you is the argument. We are talking of categories, all men are mortal. Then we are talking of the individual, Socrates is a man, and then we are concluding that Socrates is mortal. Now, his logic was quite interesting. Logic is one of the fields which historically has been studied a lot by humankind. We have been focusing on Greek logic here, and I had mentioned in passing that Indian logic also had the study of arguments. So, Tark, if you remember Tark Sangrah, logic has been given a lot of attention in the past. If you go to this site from Stanford University, which will talk about Aristotle logic, you will find quite a few fascinating things essentially. It is just that at the time of Aristotle and even in Indian logic, because these algebraic like symbols, the symbolic logic was not invented. So, it tends to be a little bit verbose, and we have already mentioned that one of the advantages of using a formal language is that it can be compact and concise. So, I do, if you are interested in Aristotle's logic, then I do recommend that you go to this website, and there are other websites also, which will give you some idea of what is the kind of reasoning that the Greeks were working with essentially. We are moving towards the first order logic that we want to study here, and we will see that first order logic basically deals with relations on a domain. So, propositional logic was in some sense in the air essentially. You just said okay, P is a sentence, Q is a sentence, P implies Q is a sentence, and R is a sentence, and so on and so forth, and we just left it at that essentially. So, the only thing that we were willing to talk about is that we can give truth values to that. So, we had a valuation function which would give truth values to those sentences. As far as meaning was concerned, it was totally devoid of meaning essentially. Now, we are trying to in some sense formalize the meaning a little bit and say that okay, this language that we are devising is going to talk about a particular domain. So, for example, we are going to talk about all the students in a class, or all the office workers in an office, or all people, or all numbers, all kinds of things. We can say this is our domain, and we are going to make statements about that domain essentially. And those statements will be in the form of relations, the mathematical notions of relations. So, for example, brother is a relation. So, if you said Suresh is a brother of Ramesh, then we know that there is some well defined relation there, not human relation, mathematical relation. So, we start when we talk about first order logic, we talk about a domain D, which is also in many textbooks called as a universe of discourse. So, we can write D here, or we can write U here, depending on what is your preference. It does not matter, it is a name, and that domain is what a given language is talking about. So, that is a world in some sense of the sentences in the first order logic. Now, categories or classes are unary relations or subsets of D. So, later on in the course, we will also look at something called description logics, which is basically concerned with categorical statements essentially. So, it is also called as a logic of noun phrases. We can say, for example, statements like the set of men is a subset of the set of mortal entities, or all men are mortal, and that is what we are trying to get to while drawing these Venn diagrams. So, the universe is this large rectangle that you see, and mortal is a category. So, it is basically a subset of the domain, and with the common property being that everybody in that subset is mortal essentially. So, when we say something like all men are mortal, then essentially we are saying that there is another category called man, and this category or the interpretation of this category, as we will see, is a subset of the interpretation of the category mortal. In other words, the set of men, and by men we mean both men and women. In generally, when you say all men are mortal, we basically mean all human are mortal, but that is how language tends to evolve essentially. That argument says all men are mortal. what we are saying is that the set of men is essentially a subset of the set of mortal people, or in other words the set of men is contained in the set of mortal people essentially. So, if anything is a man, that anything will also be a mortal. Then we make a statement Socrates is a man. So, we have individuals now. So, we have added an individual called Socrates, and we have said that Socrates lies in the set of men essentially. Now, because the set of men is a subset of the set of mortal entities, it is logical to conclude that Socrates must also be mortal essentially, because men are mortal essentially. That is the intuition behind the kind of reasoning that logic captures, and in particular we are talking about first order logic. It is also called predicate calculus. The meaning of semantics, the meaning of the semantics in propositional logic was externally defined. We simply said that this statement is true, this statement is false. So, for example, we said R implies T is true or something like that. It was given externally essentially. The semantics of first order logic is defined over a domain, as we just said. The domain D is a set and has individuals in the language that we are talking about, first order logic, which is also called predicate logic. Individuals may be named or they may be identified. So, we may talk about Socrates for example essentially, or Aristotle or Sumedha or Alice or whatever. Individuals may be named essentially, or we can talk about numbers also, number 7, number 23 and that kind of thing essentially. Individuals may also be unknown or variables. Of course, we have already encountered that notion of variables in algebra. So, we say x is equal to y plus 3, if y is equal to 2, what is x. So, these kind of very simple things use variables. So, variables are saying that okay, I am talking about some entity, but I do not quite know which entity I am talking about. So, it could be any one of the entities which are possible. So, individuals may be either identified, and we are talking about first order logic here. FOL, we will use the term phrase FOL for that. Individuals may be either named or they may be variables. FOL is also called predicate calculus because of the use of predicates essentially. Unary predicates are predicates of arity 1, or they take one argument and are interpreted as subsets of the domain essentially. So, men, mortal, animal, bright, whatever. Binary predicates are binary relations and they will be subsets of D cross D, where D is the domain essentially. We will look at these concepts as we go along. FOL is a logic that breaks down a sentence into its constituents and relations between them. So, between man and mortality for example. So, that is no longer treated as an indivisible or an atomic sentence. FOL also has a vocabulary to talk about all and some. So, you can see that that is the power that we will get by using something called variables. So, we can say for all x or for some x something is true essentially. So, all men are mortal is the example that we have seen. So, let us look at predicates and individuals in a little bit detail. So, this is, as I said, the universe of discourse or the domain D, and individuals are members of the set. So, this is a set, the universe of discourse or the domain is a set, and individuals are basically members of a set. Individuals may be constants, as we have said, for example, Aristotle, or it may be Socrates, or it may be an individual called Ted, or they may be unknown, in which case we use a symbol which we call as a variable symbol, like x is the most commonly used variable symbol, and we say that x is a individual essentially. We have not said anything about x so far, or about Socrates or Aristotle or Ted. We have just said that these are individuals. Some of them we know and some of them are kind of unknown, that we do not know who that x refers to or what that x refers to. So, predicate, we said there can be unary relations. So, for example, Socrates is a man, Aristotle is a man, X is a man, we might want to say, and that the meaning of that is that okay, there is this set of men which is shown in this red circle here, and all these three individuals, Socrates, Aristotle and X, belong to that set, and that is the meaning of these unary predicates. A unary predicate refers to a subset of the domain. So, the subset is called men in this case, and the domain is of course the universe of discourse. If you say that Ted is a dog, then essentially we are talking of another category called dog, and we are saying Ted belongs to that category. So, it is a member of the set of dogs, and we have the set of rocks, for example, and the set of mortal entities, for example, and here we are kind of showing that rocks are not mortal essentially, in the sense that rocks do not die. Of course, they may erode and that kind of stuff, but that is a different matter. We can have binary relations. We can say, for example, that Socrates was the teacher of Aristotle. We can say that Socrates had a pet called Ted essentially. So, that is only saying that there is a binary relation between Socrates and Ted. It is not saying anything about the fact that Socrates is a man or that Ted is a dog. It is only saying that there is some relation. So, if we just list out all the entities who have pets, then we would have them as some sort of a table: entity 1 pet 1, entity 2 pet 2, entity 3 pet 2, and this row would form a row in that table essentially. So, that is predicate logic and so on. Let us take a break here, now that we have got a bit of an overview, and we will come back and study the syntax in more detail essentially.